Alright, time for another draftphysics.com, debatephysics.com also. Video presentation. So the SciDeb guy has gotten back to me with a comment, so that's excellent. So we can have some two-slit type, slit anyway discussion. And so first, I guess I should say some really brief stuff. And just to point out what I believe so he understands that without having to watch a bunch of the past videos and all that kind of crap. And perhaps it's a courtesy and it's nicer that I make a video to him and all of that crap. That'll be some excuses anyway. So the first thing I know, okay, I have reasons to believe, which I'll just say that all forces are the same stuff. It's all moving the same speed. So really all it is about patterns. So you have this stuff in the universe moving the speed of light. I'd say it's Einstein's correct. It's little discrete bits of stuff. And the reason why I say wavelength is only because science uses those words. So everybody always uses words like wavelength and frequency to mean anything with a period. So I could say I could throw baseballs and there'd be a wavelength between the baseballs, right? Mathematically. But we know it's not a wavelength, it's just a distance between the baseballs, right? But we call it a wavelength, right? It's just a practical thing. So I'm arguing that photons are bits, right? And the frequency is the time between the bits, okay? So the wavelength is the distance between the bits, and the frequency is the time between the bits, right? And it's going the speed of light, and blah, blah, blah. They're inverse quantities. One's going up, the other one's going down, blah, blah, blah. But that's all semantics. And then the third issue is polarization, and that's where you get a real idea of what light is because it can't be what they say it is. Like an atom, an electron can't produce a whole photon all by itself. Okay, so a single electron or an atom, you can't have one of those little squiggly photons pop out of an atom, because we know a photon is gigantic, and some part of it is really big because a polarizing filter, there's a certain size where all of a sudden it starts working, and there's a size where it doesn't work. So if you have it too wide, it doesn't work, and all of a sudden there's a place where all of a sudden you start screwing around with the light. So the polarizing filter is basically telling you there's a size to a photon and it's big. You need a bunch of atoms worth. Not just one atom, not 10 atoms, but probably hundreds of atoms of thickness before you can screw around with a photon. The filter has to create narrowness, that's in that kind of range. So the argument is that photons are really bits of energy that have been produced by a surface at a time. So just like a radio wave in a sense, the electricity goes through and it causes an effect sequentially. It causes it here first, and then here second, and here third. So each bit has been launched at a different time because of a stroke of electricity, you could argue. And so the point would be is the photon is little bits of discrete momenta moving the speed of light, and this would be its polarization, a little bit out of alignment. Okay, and so the wavelength will be proportional in most cases to the polarization. So the 3 centimeter antenna for the microwaves is sort of a reflection of the fact that the frequency is narrowed, and so has the polarization. And as you get smaller and smaller and smaller, it gets to be smaller polarization and smaller distance between, and then you get into X-rays and all kinds of reasons why they penetrate through things and all of that crap. So this has to hit at a surface, and it has to hit a surface of atoms, and it basically hits one atom, gives its electrons motion, then it hits again another atom, and that creates even more vibration, causes more momentum to the electron, then it hits again, causes more action to the electron, adds more fuel to the electron. And so it's just about the timing and hitting behind it, and basically keep adding a little bit of energy to the electron until you make it go fast enough that it causes the electrical impulse, the release of an electron. So that's the basics of the photon. It's not a ray, okay? It comes in rays, but it's not in clumps of ray, as you're sort of describing. You can't have a 10-mile long ray, like in the case of radio waves. You just have 10 miles between a whole bunch of these little bits. Like a radio wave would be, there's a whole bunch of them, and then there's nothing for a mile, and there's a whole bunch of them, nothing for, a whole full second. 1 hertz would be 1 full second between these clumps of these particles. All right, so that's probably enough of that background. And I'll erase. All right, as you probably noticed in the other videos, I do have theory, okay, as to how the slit experiments work, and it's basically, the fact is that most of the photons go through the openings when they're wide enough for photons to go through. They go straight through, and the only ones being affected are the ones by the surface. And what we learned from one of these other videos is the guy basically lengthened, okay, the surface, and the other guy has a very narrow, razor blade surface. So I was thinking about those two circumstances, and guess what? Your razor blade, you think it's really thin, but atomically, it has an edge. Okay, maybe it's only 100 atoms or something. Maybe you can reduce it to a very fine point, but even when it's a very fine point, it's not exactly a fine point. So it really does have two edges, and as I pointed out, charge has a hard time dealing with corners, and so charge always bulges out at corners. So you would understand that, there's a higher likelihood of hitting electrons at the corners. And the fact is, you could hit it twice in this scenario. You could hit it once here, and then it hits it again here, and these essentially become two different sources. And so you can end up with an interference pattern in the sense you can send something from two different places to the same location. And the whole argument basically is, my argument is, obviously when these sources match, where they come from these different sources, they're just recreating the photon. That is, they're giving it the correct timing. If they don't match, well, then the timing looks like this, and that's off. It's too close here. So it's not going to be a photon. The energy is not going to hit the surface at the right timing, and it's not going to create electric impulse because the timing's way off, and it's not going to give the electron the necessary momentum. And obviously I've pointed out, as I think you would know by now, that the math works perfectly, that this distance ends up creating the little dots, okay, and this smaller distance ends up creating the envelope pattern that the two slit is classically known for, okay. Where there's only 3 here, 5 here, 3 here, 2 here, 3 here, 2 here. You could have, just keeps going. You could have 5 here, and you'd have 9 here. Always one less, because this is basically an overlap of the two patterns. One shooting through here, going that way, the other one going this way. Okay, so I drew all that already, so you should have all that stuff. But this corner thing is very interesting, because even a tiny razor blade still has the two corners. And so that's how the straight line is being created. So you can have one edge, right? That's what was shown. And I found it to be very sensitive. And I thought of that, and I said, gee, why is it so sensitive? Why do I have to fiddle with this? So let's say I have the straight edge. I just have a little tiny edge. Okay, and I'm going to go across it. It really does have two corners. And what I found is my laser beam has to hit very particular. If I don't push this in just right, I don't get the straight line, right? I don't get light diffracted in both directions. And I use the word diffraction. It just means, if it really is the case that what we're doing is we're hitting something that's moving, and we're hitting it with some other thing that's moving, a little thing, and it's changing the direction of the original thing, you don't call that a reflection. It obviously is a compound reflection. It's a diffraction in the sense that you've deflected the object. So it's not as simple as just saying deflection or reflection, because it frankly is a combination of the two to create the outcome. So I don't think there's anything wrong with using the word diffraction. It's not just for waves. It's for anything where you have a compound interaction. Okay. So, I don't want to get into the semantics, but shit, it is. So the interesting thing is when you think about this, the laser beam actually has to be lined up with the surface. So if I don't line let's say there are two interactions happening, one at this intersection and one at this, whatever you call this corner. So there's one happening at this corner and one happening at this corner. that would require this beam to be, see, if the beam isn't coming in straight, well then I only get one refraction. I only get one diffraction. So I don't have two sources. The light doesn't go here. And if I have it pointed this way, you know, obviously all the stuff I'm deflecting this way just reflects off the surface, doesn't go the right way. And so all I get is one arrow going this way again. So I don't get two sources. And the way I get two sources, I have to have perfect alignment. And that's why I was noticing, gee, I can only get this straight line if everything's just right. It's very sensitive, very sensitive. And I know, you know, I even said that in my video. I noticed it was kind of sensitive. And so that adds up. So I think we got a new feature we can add because of that. I find interesting. So you're really saying you're just looking to make new sources of photons. And the new sources are really broken ones is my argument. Obviously the single slit is breaking the photons that go by the surface. It's taking things that have this pattern, you know, and it's cutting one of those off. And then you're taking this other surface, right? So this surface sends dot, dot, dot over here. And then this surface just sends the extra dot. Let's say you need 4. And so now that's going to be a photon. And that explanation does, in my opinion, satisfy all the credentials, all the requirements of being a perfectly valid explanation. All right, I think that's enough background, and then we'll start reading. All right, so leave us read. So SciDeb. Hey there, it's me again. I'm not the type of guy to hold a grudge. Well, either am I. And frankly, it's just like playing pool or something. You know what I mean? I'm playing pool. I don't really care who I'm playing against, right? It's nice if it's somebody I like, but sometimes that makes it worse because, you know, you don't want to have to beat your best friend and all that kind of... I actually had a big fight with one of my friends as a kid. You know, basically we bet $5. I won. You know, he lost the $5, and yeah, the $5 was a lot of money back then. And he didn't pay. You know, and you know, I guess got kind of in principle pissed off. And you know, he didn't pay. Well, look, I had a job. I was a paper boy, this and that. So you know, $5 wasn't, you know, didn't mean much to me because I had money and he didn't have a job, and so he had his allowance and blah 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 blah. So maybe he just felt like I was already well off, you know, he didn't have to pay me or something. Well, anyway, it's just a sad story. And then he moved. You know, we cried and said goodbye when he moved and all that crap, and you know, let it all be bygones, be bygones. But it was really, frankly, it's one of the more tragic moments of my life. Frankly, you know, I'd never had a better friend, and it's just all, life sucks. Anyway. This is the internet, and anonymity is often responsible for a lack of filters people may have. I don't even understand that part at all, frankly. You know, I just don't. You know, I just, you know, if you had to live next door to the guy, I could see how it could matter. But I can't see how it matters what my name, if somebody knows my name, as long as they're not going to come knocking on my door, who the fuck cares? You know, so that part I don't really get. I try hard never to be arrogant, but I'm far from being perfect. Yeah, it's okay. I sort of made the point. Look, I mean, you're a little bit rude. No big deal. Okay, let's get both get over it. So I apologize for my comment about photon particles. Yeah, it doesn't matter. I've already long forgotten. Why is the rest of this not showing? Anyway, let's see. I noticed it pissed you off. I'm just saying it, you know, get this shit a lot from people, and I'm just saying I don't have any patience for it. So as soon as somebody starts pulling triggers, and I'm like, you know, come on, let's not pretend you can't figure out you just pulled the trigger. Okay, something I don't quite get though. You're saying light is not a wave. That's right. But on the other hand, you always mention frequencies and wavelengths. I'm just saying you really can't talk about anything that comes at a period, okay, without talking about frequency and wavelength. That means two fundamental parts of what something at a period does, okay? It's just a fact that if I throw baseballs outside, or if I hit golf balls, or I do anything else, you know, at a regular rate, it's going to be significant, the distance between where the balls land, you know, and then how often they land. Those are going to be really interesting features. Isn't that contradictory? No, it's just semantics, so get over it. The wavelength was a poorly chosen word, okay, because There's lots of things with periods that don't have wavelengths. Cannonballs, lots of things. I mean, they had catapults back then, okay? I mean, are we going to say because the catapult can fire every 2.3 minutes, that we're going to pretend again that there's no wavelength in the frequency of the shit you're shooting? Of course there is. Okay, isn't that contradictory? No, I know you don't like repeating yourself, but could you explain why? Okay, so I think I've already explained it. I mean, fuck, I didn't invent the word, all right? I mean, it should be called something else, the period length. Something like that. I mean, that's what it should be called. That's a more precise description of what it is. Period length, okay? And what kind of emission mechanism would be creating photon frequencies? Well, the emission mechanism is called an electron, and every time it moves into the universe in any way whatsoever, it's hitting force, okay? It's hitting cell phone calls, it's hitting radio frequencies, it's hitting gamma, it's hitting all kinds of shit moving the speed of light. And what it's basically doing is saying, look, when I hit you here, I just changed where you're going and how fast you're going, and not how fast, but how soon you'll arrive, because I've shortened the distance, right? So if you're coming home from work I punch your car in the opposite direction, it's going to take it longer to get home because I've added distance to your travel. Anyway, artificial radio signals. Well, it doesn't. I don't even know why you would qualify one as artificial or natural. They're all radio signals because of their frequency. The frequency is the only thing that gives it the classification of radio. Radio is just a class of frequencies. Okay, but it's all photons. For instance, require an oscillator. So what? And yes, that's what everything's happening. So every time electricity goes through a wire, it oscillates the atoms. Okay, the fact is the electrons in the atoms end up being pushed out, okay, as electrons are moved through the conductor, and the shape of the atoms effectively changes, which is their polarization, which ends up being magnetic. Their north-south orientations change. That's why they become magnetic. What's nature's oscillator? Okay, the nature's oscillator is the electron. And the electron can be moving very quickly or it can be moving really slowly. And that's the difference. The faster you move it, the more likely it is to produce some sort of signal, frequency, vibrational frequency that will be detectable by some other object. You might say vibration, but and again, this is critical to the only good work Einstein did, which is this whole work of talking about light quanta and talking about the fact that there is a photoelectric effect and that there's Brownian motion, and that the Brownian motion is actually being caused by electron motion. But again, what is the mechanism for the vibration? Electrons and protons, charge, essentially. And the fact is that everything is being plummeted by the universe. So right now, I would argue you're oscillating in gravity. Right now, gravity does in fact push you every billionth of a second, every quadrillionth of a second. You're getting hit by gravity. It's pushing you into the ground, and the ground pushes you back up. So right now, you are vibrating on the Earth. And this is key to another one of Einstein's, to relativity, in the sense that the bullshit arguments about velocity. But the fact is things on the close to the surface of the Earth are vibrating a lot, more gravity. Things further away vibrate less gravity, you see. So, how fast you're moving down, requires the Earth to push you back. Higher the pressure, the higher the velocity of the vibration. So, actually, satellites are actually going much slower, right? Even though they're speeding across the sky, they're actually going slower than us because we're doing this the whole time while they're doing this the whole time. So we're a bouncing basketball that's really going a lot of distance. The player's going pretty slow, but the ball's going a lot of distance. Okay, that kind of thing. All right, creating photon frequencies. You might say vibration, but again, what is the mechanism for vibration? Okay, I'm not a mathematician, thank goodness. Don't go anywhere near that horse shit. They're all idiots. No, I mean, there's, some math is 2 plus 2 is really kind of good to keep track of that kind of stuff. But anyway, it's not a math argument, okay? It's just the simple fact is you can notice you're going up and down in gravity, but you can notice, hey, my ass is getting tired. Why would it get tired? No. All right. I like real physical mechanism. Yeah, that's yeah, it's a lot more fuckable. The physical mechanism. I am hot for it also. So please, no math, because it's a language of description I'm not fully comfortable with and frankly don't care for. The fact is, math is a formalization of the existence of a relationship. So the fact that frequency goes up completely proportional to how wavelength goes down is kind of just a nice mathematical correlation. So you can use that, okay, to your advantage in an equation. It's a nice little gimmick to play with. Yes, those associations and those relationships are interesting, okay? The fact is there are things tend, okay, Galilean math, right? 1, 3, 5, 7. The idea that you're gaining and gaining more and more velocity, okay, proportional to the time you're in gravity. That's good math. Anyway, I need explanations, not descriptions. I like drawings. Drawings are really great. Okay, math does not explain. Yes, well, I don't do math videos, so you really shouldn't be that afraid. Okay, I'm actually a particle guy myself. Yeah, except you're going to say stuff that doesn't sound like that, but okay. But I see particles as individual rays. Well, yeah, I'm sorry. See, this is a language thing. You're complaining about wavelength and saying you can't figure out why I would use a word like wavelength. Well, because that's the word I have. Now, particle and ray, these aren't complicated words. I mean, ray is not a particle, so come on. That's why there's two different words, is because it's two different things. Particle is little thing, discrete little tiny thing. Ray is long thing, big giant thing. Okay, and I would argue there are no real rays. Okay, the ray has to be made out of particles. So ray is an emergent property in the sense that it's the way something looks, not the way something is. Nothing rays through space. Okay, things have to move through space, okay, and they can look rayy when there's a whole bunch of them. So if I line up a bunch of people, they can look like a ray of people. But, we know it's not a ray. We know it's just individual people lined up in a ray form. All right. Emitted as such. The rays may be continuous. So we could probably agree. You're saying particles are made out of rays. Make rays. That's okay with me. So a whole bunch of particles really close together is a ray. Yes, I'll agree. Okay, but, in this case, like radio waves, it's really not about a whole bunch of people lined up behind each other. It's like a whole line of people this way. So instead of being lined up this way, there's a line of people this way, and then there's a line of people this way, and then there's a line of people this way. So they're coming more wave-like. There's like waves of people. So ray and wave are ways of describing how particles can behave. Maybe we can agree on that terminology. And sometimes the particles can be arranged to look like waves, and sometimes they can be arranged to look like rays. But they aren't either one of those things. Elementally, they're just particles. Okay, the rays may be continuous of a certain length depending on the emission itself, its intensity, and its duration. I think I've summarized that well enough, blah, 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 blah. And still, I don't understand why you don't agree with my interpretation of the double slit. Well, your interpretation is saying that somehow because you can show the pattern, okay, over a great deal of distance. So what he's doing is taking smoke and then doing the double slit and saying, look, I can see these lines of light. And my point is all you're really doing is taking the target and you're moving pieces of the target to all these different locations and saying, look, it's making the same pattern, just smaller. Yes, that's exactly what the wave theory says. The pattern is very small, okay, very close to the surface, and the pattern's very big, far away from the surface. So they're going to make the same argument. So it's going to look like lines, in their case of waves, also, because they do say the photon terminates as a single point. Okay, so the wave terminates when it hits the target. You're just moving particles of smoke closer to the light source and then saying, look, I moved the target here, okay, and the photon terminated. Well, they agree. It will terminate if you move the target here. And it will look just like what you're saying, you're seeing. So I'm just saying it doesn't really solve the problem. All right, and then to solve the problem, to say that it's actually going to prove something, that's where math comes in. Because see, the math of circular waves says that the lines have to have they do this, okay? They have to do this. And the argument is if they don't do that, if you can show with your argument that they move in a dead straight line, dead straight, then you can defeat their theory. Okay, am I correct to assume you believe every point where light hits becomes a new source? No, it becomes a target. It's the end of the experiment. You've concluded the light's voyage as a two-slit experiment. Now you're just reading it as where it ended up. That might apply to waves if they existed, but I say the double-slit experiment only shows reflection. So clearly it doesn't show just reflections. I mean, clearly there's an on-off pattern. You have to explain how it reflects in that manner, okay? Because it really just can't be just about a reflection. If it was just about reflection, it wouldn't create a in phase, out of phase pattern. Point out, because the two patterns would end up overlapping each other in the sense you wouldn't end up with a perfectly even pattern. Deflection and reflection are wave phenomenon. So diffraction and refraction are wave phenomenon. So again, those are the uses of the words traditionally, but I'm just going to argue to you that's only because they thought everything was a wave. So that's not my fault. The fact that they couldn't even conceive of having a conversation about baseballs or bowling balls or cannonballs or arrows or rocks or birds or any other fish, because they can't imagine anything else in the universe except waving things, isn't my fault. Okay. These are real phenomenons that take place where something goes in going one way and it comes out another way. That can't be said it's always a wave. Yeah. We're discussing here, so I'm only looking to make sense of all the assumptions made in the light theory. So they're not all assumptions. I'm not trying to make a sense out of the assumptions. I'm trying to take all the facts that we can collect about what a photon is. So it's the size of its polarization. I'll argue we have evidence of that. What's its source and what does it end with? Well, we know that most all the time that if we're going to actually measure a photon, that is, measure its arrival somewhere, we have to do it by creating electricity. Our brain makes electricity out of the photon. Obviously, all our mechanical sensors make electricity out of the photon. They never see a photon. They see the electricity the photon creates. Obviously, the radio signal has to be created by electricity. There's so many examples of that. What the real phenomenon is that there's this huge connection between screwing up atoms electrically and creating and receiving photons. So there's all these little facts that we could all add up and say, then we can figure out if a model fits the facts or doesn't fit the facts. So it'd be important to list all of these little facts. But seeing we appear to be two of the very few people in the world who reject the wave theory of light, the wave theory of anything. Yes, the ether theory, whatever you want to call it. Yes, we're the only ones who think things don't just... I don't know whether you understand it's a push universe, but frankly, there's no elemental pulls. There isn't anything in the universe going, come to me, because I say so. That just doesn't happen. Perhaps we could help each other out a little, or at least consider or study each other's ideas. Yes, we don't have much of your ideas available, so I couldn't really study them yet. So just make more videos or produce more content somewhere, so then I can take a look at that. Yeah, that's really the whole point here. It's really the challenge is that there are a bunch of little facts out there, experiments that have been done, and from all these experiments, we can glean information about how the real thing works, and we can just forget about the Bible produced by physicists. Okay, we could just say this silly Bible isn't going to be a good source of information. So let's go, bang on some rocks. Let's go look for some fossils. Let's go do something like that instead, because we're not going to get anything from them because they couldn't be bothered. Not asking to go have a beer, just being a little more friendly than how we started off. Yes, that's good. It's good to be friendly. It's good not to be butthurt and pissed off and all that kind of crap, and dishonest anyway. Look, I'm a very honest person, okay? I don't have an agenda besides saying, yes, I love finding right answers. That's fun. You could be saying it's needle in the haystack or something. Yes, go ahead, throw a needle in a haystack and I'll go find it because it's fun to go find things. Anyway, maybe I'm just that retarded. I just want Easter egg hunt. I love Easter egg hunt. Oh, it's fun, Easter egg hunt. That's me. Anyway, don't get me wrong. I actually appreciate your style and that you are not the politically correct type. I am in some ways. I don't think you should be, saying something. I don't think you should just throw out the old N word anytime you feel like it or any of that shit. Some theories are laughable and downright insane. Yeah, they're all. Frankly, I'm down. It's just you can't even. These people are so brain dead. It's like every single thought they have is upside down, crooked, dirty, bent. Bent. Everything they touch is bent. Okay. There are so many loonies out there, even some with valid credentials. Well, frankly, the more credentials they have, and the simple truth is the wackier they get, and the more arrogant they get, and the more cement-headed they get. So, yeah, we're fucked. That it's freaky scary. No, it's freaky depressing for me, but, I try to get over it. I'm not interested in arguing. I love arguing, frankly. It's the only way to get through all the crap, It's just a fact. You gotta argue about some of the stuff. We're going to decide to go search in the fucking haystack for the needle. And, frankly, I saw the guy throw it, and I know from the trajectory it has to be in that half of the haystack. And you're like, oh, no, let's do this methodically, and let's start from the left and move to the right. And I'm like, no, I know it's in the right side, fucker. We're going to argue because, frankly, I don't see any point in wasting time looking in the side that fucking thing isn't in. So, anyway. So I'm always interested in arguing because, frankly, there is more efficient ways to do things. There are better ways to do things, and everything needs to be argued because, frankly, the people's choices aren't very smart most of the time. Just understanding and respecting each other's point of view. Well, see, I don't want to do that respecting thing of a point of view. I'll respect you as a human being, and I'm perfectly comfortable with that, and I'm comfortable with you calling me a jerk or an asshole sometimes and all that shit, but I'm not going to respect points of view that are stupid, and most people have stupid points of view. They're just saying, well, I know Jesus exists, so let's go find evidence that Jesus exists. No, I'm not. No, that's stupid. Okay. Anyway, especially when it makes sense. Okay, whatever that means. Yeah, so that's the part. The average person can't figure out the simplest things that make sense. It's a push universe, for example. It makes perfectly good sense that push is so easy. You can mechanically make a push without even trying. It's, oh, push! I did it! Oh, push! I did it! But pull? Okay, this one sits there and it okay, this one, you can't make a pull. It's like Rain Man. Why do I even have to have a conversation about push and pull when it's just so fucking obvious? There's no elemental pull that doesn't involve woo. Anyway, but I'm not a physicist, either am I. But I play one on the internet. So if there is something you believe I am not understanding, please let me know constructively. I always try to be constructive, you know. Yes, just let me know if I've hurt your feelings in some way or disrespected you or in some way made you feel small and insignificant and, you know, unimportant. Let me know and I'll do it again. No, I'll try to not be an asshole. I don't like cheers, so I'll just let you know. Never say cheers to me because I don't get that shit. What the fuck is a cheers? That's some sort of British thing, right? Ew. Ew. It's so... Ew. It's like saying groovy. You know, if I make an agreement that I'll never say groovy to you, will you never say cheers to me? Okay, thank you. All right, so now we got all that out of the way. Super. So anyway, great comment. I love great comment. Okay, really didn't get too abstract, didn't get too bizarre. You just laid out simple little problems, and so now we can move on from there. So very good. Excellent. Excellent. But I should let you know, okay, I am an expert on the double slit. Okay, I have seen every video on YouTube. I don't think there's a single one I haven't seen. I've gone on the internet, looked at all the different kinds of experiments inside of electron microscopes, inside the, you know, every single freaking experiment I could possibly find. So I really am, I know my two slit data. Okay, yeah, I know it. Inside and out. Veritasium video, all these videos, all this bullshit. The history of it, you know it all. All right, so anyway, till the next time. So I thought that was very constructive. Excellent. Very good. Excellent. Yes, very good. Yes, so you'll leave it there. Very good. Excellent. Yeah, I'll reverse it like the frequency. Okay. Till the next time, and such, and so forth and whatnot.